Ready? All right. Hello, everybody. Welcome back to Project M.O.V.E. With me, Dr. Josh Weidman, myself, Matt Markey. And last week we kind of talked about uh, really kind of getting better at developing fast twitch muscles. This time we're going to talk about how to get better at slow twitch fibers and kind of maybe talk a little bit about the anatomy, but then also kind of function of both, and maybe get a little bit more into the clinical side of things. But yeah, we should have by the end of today just a good understanding of how we train those, and yeah.
Yeah, so the fast twitch are clearly important for certain aspects, but clearly we need slow twitch as well. So I think part of the discussion will be on kind of the depth of tissue and how the slow twitch fibers tend to be a little bit deeper. Fast twitch fibers tend to be a little bit more superficial, and so we don't necessarily want to confuse the training systems and why we would be trying to do it all at the same time. So I think allowing each to kind of like serve its own purpose allows us to kind of specify a little bit more clearly to give us a better result.
Yeah. Okay, so first off, let's kind of talk about fast or slow twitch fibers, which are going to be type 1 fibers. And with type 1, we typically see much more myoglobin content, which gives it a much more of that reddish appearance. And what that allows us to do is with that more myoglobin, we have essentially more blood flow to the muscle. So we're actually able to get much longer duration of time under tension out of those muscle fibers. Typically also tend to be a little bit smaller and deeper where kind of movement happens first. So as far as like I said, having that more myoglobin, it's a little bit more time under tension. We typically see type 2 fibers. We're looking for, in order to really target those, having a time under tension somewhere north of like 2 minutes. Getting out of that glycolytic pathway and moving into the oxidative phosphorylation.
Mm-hmm.
We're using kind of more fat and fatty acids for fuel.
Yeah, I think we need at least 40 seconds, like minimum, and then towards that 2 minute mark.
Yes, and then once we kind of depleted those glycogen stores, our body then will really start tapping into more fatty acids for fuel. It's not going to give us as much energy. We're not going to see as much power output, but we're going to see as much longer duration as far as how much energy we can get out of those.
Which is why, aerobic training is heavily more biased towards the type 1 fibers where we're utilizing that aerobic system.
Yeah, and in order to do that, we have to be able to keep constantly pumping energy into it. So we see that more myoglobin, more mitochondria, to where we can kind of keep regenerating ATP. So it comes with its own trade-off. Because we're able to go longer, we're not going to see as much force production.
Correct.
And typically we see more of our slow twitch fibers the deeper we go, more in our postural muscles. So yeah, I know, Josh, you typically deal with a lot more, I guess, slow twitch fiber training, just because you're more in the clinical setting.
Right.
I typically see a little bit more fast twitch on my side. Definitely still kind of tap into it with CrossFit, but yeah. So let's maybe kind of talk about why we see it deeper first.
Yeah, so if we take the spine, the multifidi that are the deepest right next to the spinal segments, just after an injury, we will see that those muscles tend to be kind of almost like put off to the side to a certain extent. And so we tend to see atrophy. We tend to see fatty infiltrate, where instead of actual muscle tissue, like fat is created to basically fill in the gaps. Long story short, those muscles lose their efficiency, and now we're relying on more of the fast twitch to provide both the stability aspect and the movement aspect. And so a lot of times the key in rehabilitation is regaining that slow twitch fiber contraction to be able to not only stabilize the joint, but to provide that almost smooth contraction. Because a lot of times, whenever we see the fast twitch take over, we see this kind of like ratchety, like very uncontrolled type movements. Whereas if the slow twitch have their efficiency, we see a very kind of smooth, controlled type movement. And so, as the person is developing better control, we start to see that fast twitch become less of the dominant, and we see the slow twitch kind of take over. And obviously we need both, but in the early stages of rehab, regaining that slow twitch is really a lot of what we tend to be working on.
And that kind of makes sense that it's the deepest stuff because it's where movement happens first. So we need to, in order to go through a certain range of motion, we have to have some sort of level of stability before we can really put force behind it. So basically surrounding the joints with more slow twitch fibers, we can kind of stabilize it, and then we can really develop those fast twitch. But today we're talking about slow twitch. So how do we train specifically slow twitch? We said we using our energy pathway of oxphos, so oxidative phosphorylation, more fatty acids for fuel. In order to train those and get more efficient, well, we need to spend time in that energy pathway. So
right.
This is kind of like even gets into like zone 2 training. We're trying to essentially keep ourselves from going to failure. So we're still not hitting muscle failure. We're trying to avoid that deep burning sensation.
Right.
But yeah, trying to push it somewhere north of 2 minutes. And we can kind of tailor it more specifically to our specific sport. So if we're more of a super ultra endurance, we need to keep our intensity light enough to where we're not essentially burning ourselves out, and we're able to get into those longer duration hours on end as far as trying to maximize that. Whereas if we're maybe more of like a mile distance runner, where we can kind of now try to bias our time under tension to favor more of that 4-minute mark.
Yeah, and I think there's still a delineation between slow twitch strength training and then slow twitch aerobic training.
Yes.
So even though we're tapping into slow twitch during aerobic training, I think the emphasis of what we're talking about is more on the slow twitch strength training side of things, even though we need it all to kind of blend together.
Yes. So slow twitch, trying to keep our time under tension somewhere north, not to failure. So yeah, it's kind of exactly what it says. We need to now, as we mentioned last time in our types of fibers, so we're going to see a much smaller kind of cross section of slow twitch fibers, and we're going to get a lot more of that because it's more longer duration. We're also going to get that lower decreased pennation angle, so it's going to look kind of more like this one, where the tissues are aligned more vertically, whereas in that high velocity you're going to see more of that muscle gearing and rotation to where it kind of goes more horizontally. So yeah, with this we need to kind of, and this is kind of, maybe let's go back to the kind of the clinical side, where as far as order of certain exercises, we see typically the deeper stuff, and we've kind of talked about this before as far as how to prime tissue and kind of start deep and move outward. Starting with the kind of deep, more tissue around the joint, and then kind of maybe kind of building out from there. So training slow twitch, still kind of, as we mentioned before, starting with the deepest stuff. So more of our, like if it's with the spine, more of that deep linear based tissue because the deepest stuff is linear when it comes to spine, whereas all the other joints, shoulders, hips, we see more like those rotator cuff, and really trying to train those rotational tissues first because those are going to be where movement's happening first and are going to be more uh, susceptible to injuries if we're going these longer durations, just because uh, when we compensate, I guess we can kind of compensate, and other of those like more superficial muscles, but no matter what those type one fibers, slow twitch postural that are, deepest are always going to be moving. They're always going to be more susceptible. So slow twitch training is going to be important, even if you're more of a fast twitch athlete, because it's going to give us a little bit of a buffer. So like if we're going heavy, like we see a lot of powerlifters with, a lot of like, rotator cuff, deep tissue injuries. Well, it's because it's never trained.
Yeah. So the way you can look at it is you could be super strong in kind of the husk, like the outer shell, if you will. But if every time you need to use your shoulder, if the rotator cuff's job is to basically stabilize the shoulder joint to allow the prime movers to do their job. But if every time the shoulder goes to move and there's like this micro movement that's happening, we start to see increased shear, we start to see, basically increased inflammation. And so can they still perform the movement? Yes, but it's inefficient. So if we can have a strong connective tissue background like we've talked about in previous episodes, and then now have this deep, slow twitch contraction to be able to stabilize the joint, then the prime movers have the ability to really create explosive movement on top of that. But if the prime movers are trying to stabilize and produce force at the same time, they're never going to produce the amount of force that they could if their only job was to just produce the force. So the key is the order of operations, right? So we need the contraction to kind of happen from deepest to more superficial, and that has to happen kind of every single time. So if we look at like the research on the core, there was some research done out of Australia and how before you even go to move, the brain anticipating movement already starts to contract the core to anticipate movement happening. And so if we don't have that anticipation and that contraction happen first, we're going to start to get some of those shearing motions. And so the spine might not be as stable as it could be. And so now we start to use these compensation strategies. We might lock ourselves into extension to then try to create some of this stability. And so again, it's just inefficient. And so if we're trying to produce the most force, that efficient strategy is going to be where we're able to create the maximum amount of force with the minimal amount of joint wear. And so if we're talking about longevity and how to maintain the health of our joints, it's the best strategy moving forward.
Yeah. So even if you are a fast twitch athlete, training slow twitch, especially the deep stuff, so a lot of that rotational tissue is important because it's what's going to kind of give us the support to really able to make those fast twitch movements without those kind of micro shifts and creating more shearing force and basically just increasing the likelihood of injury. So there is always a time and a place for training slow twitch, even if it's not your specific sport.
Yeah, you're not going to get slow by training slow twitch per se. And then the other little caveat, you've heard the analogy, you can't shoot a cannon off a canoe, like it's going to topple over. So if you don't have that slow twitch efficiency, creating that high amount of force in those superficial tissues is just not going to go as well.
Yeah, and then so now maybe kind of looking at more trying to optimize performance for your sport. So yeah, definitely, as we mentioned last time, you're gonna have there's a genetic component. It's like, if you're from Ethiopia, you're probably gonna be a little definitely more type 1. type 1 fibers because, hey, they dominate, the all the marathons. So
Mhm.
there is a genetic component, is what I'm trying to get at. And when we train, like I said, we know which energy pathway we're using, so now we know what time under tension we need. So we need to be somewhere north of 2 minutes. So if we're a long distance runner, maybe we're looking at, if we're trying to get better at our long distance, so maybe we're trying to look at some, now as we're moving more superficial, looking at to those hamstrings, those deep knee flexions, and just looking to uh, increase time under tension where we're taking those hamstrings to fatigue, but at a low enough intensity where we can maintain it for somewhere north of 2 minutes. And then basically what we're doing is we're now telling those fast twitch fibers those slow twitch fibers to get better at, helping us with our kick and helping us, uh, with those longer duration uh, sports of ours.
Yeah, so I think that allowing that time under tension is important. So I think that, again, this goes back to choosing the right weight, knowing that our duration is going to be much longer, or choosing, you know, the right interval if we're talking about, say, running repeat type or rowing or something along those lines, because we don't want to muddy the waters with energy systems or different contraction types. So I think the key is making sure that we're clear on our parameters and finding the right load that fits that particular.
Yeah, and this is where I'd also say with more slow twitch. So yeah, we're definitely doing lighter intensity, and this is maybe even getting more into then maybe moving into more isolation type exercises. So yeah, if we're an ultra endurance marathon runner or a marathon runner, our time under tension is, I mean, we're running for north of 3 hours for most of us. Uh, we're not essentially working the hamstrings that are not under time under tension for 3 hours. It ends up kind of getting like spread out. But knowing what tissues our body's going to use for our specific endurance sport, we can then kind of separate those and then now really develop the hamstrings, or maybe we work on those hip extensors. But we can get it a little bit more into isolation and then just definitely drop the intensity down. It's probably even to be a lot of body weight exercises, just so where you can kind of increase that time under tension under over 2 minutes.
Yeah, and I think, so
And
the
then, sorry, and then we basically then kind of as we talked before, in previous episodes, we then take that newly trained tissue and then we kind of funnel it back into our sport. So then we're essentially breaking down like our run, if we're a long distance runner, into just maybe the training component of knee flexion. We work on training those slow twitch fibers, get better at the art of slow twitch. So we keep the intensity light enough to where our time under tension is north of 2 minutes. And then we just allow that body to, if we send the appropriate signal, to adapt and get better at slow twitch. And then we just funnel it into our sport.
correct. So it's basically training the components and then allowing the body to kind of self-organize during the run. So if you took the foot and you trained slow twitch efficiency of the foot intrinsics, you took the calf, you trained the slow twitch, and you worked your way up. Then whenever you went out to run, the goal would be that the body just figures it out, right? You don't necessarily, and yes, you do, but you don't necessarily have to train running to get better at running. So if you took Kipchoge, the one of the better marathon runners out there, right?
The best.
Yeah. And so if you took him and you said, if he was in front of you and you said, how do you make him better at marathon running? You would probably find that he's maxed out his aerobic efficiency, but has he truly maxed out his slow twitch efficiency? Potentially not. And so we could then work on specific components of where in the legs he needs more slow twitch efficiency and isolate that out. And then whenever he knows how to run, we don't need to like train him how to run. But whenever he goes back to running, if you give him more, soleus slow twitch efficiency, he's going to then be able to use that throughout the marathon or his training.
Yeah. So yeah, keeping everything submaximal, taking ourselves to fatigue north of 2 minutes in that specific tissue we're trying to improve upon in slow twitch fibers. Uh, yeah, I think it's I think a lot of people kind of it's really just bringing more intentionality and understanding what is we're trying to get better at, and then understanding the tissue that allows us to do that, and really just kind of dialing in the specifics.
Yeah, I think the challenge, so we've talked about the gearing before, and so getting back to like it's a slower contraction, right? So we don't necessarily want to just create this high speed. We want to almost like slowly start to build the tension. So if we're working more on the strength aspect of slow twitch, we don't see any of that gearing. And obviously, if we're running that's a different concept. But I think that we want to make sure that we're not trying to, like you said, blend where we're doing fast twitch while we're trying to work on slow twitch. I think the key is making sure that we have the intentional, this is what we're after, and don't try to mix the two.
Yeah, and I think maybe another thing it's worth mentioning, whenever we're training slow twitch, we typically probably see more variability in our ranges of motion than we typically do from our fast twitch type of sports. Maybe this is maybe coming more from a patternized movement sort of background, like weightlifting. Slow twitch, we're going to see a lot more variable in essentially the lines of tension that we're training.
Mm-hmm.
So when training our slow twitch fibers, it's since we're going for so long, our body is going to slowly kind of maybe make little tweaks to kind of adapt lines of tension so we don't fatigue ourselves out. So getting variability in the degrees and angles in which you're training slow twitch, I think, is also something that's kind of worth stating.
Yeah, if we've talked about workspace, joint workspace, and how that contributes to the variability of movement, and how the more workspace we have, we can start to draw in more biology. And so that goes right along with what we've been talking about, because like from the clinical side, the joint workspace is something that I tend to prioritize. And so sometimes the joint workspace can be a little bit of an abstract concept to most people. So starting with this slow twitch component might help them feel what we're trying to achieve more from a muscular standpoint than a connective tissue standpoint. And then once we start to like establish, oh wow, you're really shaky in this zone, then it's like, okay, well, how's the range of motion in that zone? It's also limited or challenged. And so then we start to draw in these, okay, that's probably where you're lacking workspace. So if we can start to establish improved workspace in that area, we start to also see better contraction, a little less shaky, and then we can start to build into, creating this more comprehensive plan, if you will.
Yeah. So, kind of reiterate, slow twitch, we're looking to, efficiency, keep our time under tension somewhere north of 2 minutes, but not going into that burn. We're allowing some, I guess, more cerebral reps in reserve, so that we can basically tell our body to adapt and get better at slow twitch. When we're going that north, we're kind of using more of our aerobic pathway. So, and that's kind of what I mentioned before about doing some zone 2 training, trying to increase mitochondria production. Basically, we're trying to do anything we can to increase our work duration.
Mm-hmm.
Other things, even if you're a fast twitch athlete, it's slow twitch is important because one, it's going to be typically our deepest stuff. It's going to allow us to stabilize those movements we're looking to do fast, but also training that allows our fast twitch actually aids in our recovery because doing these lower intensity, longer volume, we're increasing blood flow. Even though we're training our slow twitch fibers, our fast twitch, it's just basically it's going to help increase blood flow. It's going to help with the recovery from that standpoint.
Correct. So, we talked about that 30-second minimum to recycle the ATP. And so if we're more efficient in these type 1 fibers, I'm not saying that you can speed up physiology, but it's going to be closer to that 30-second mark rather than the 1 minute or even two. Like so we can have things happen on the faster end of normal, if you will, rather than the slower. And so if we're not efficient in the slow twitch, whenever we're doing our fast twitch training, it's going to take longer to truly replenish. And so it's one of those things like we need both. We can't just train fast twitch only. We have to have both systems working to optimize performance in general.
Yeah. Yeah, I think that kind of sums up slow twitch. Keep things long, keep things light. And
interestingly enough, if we talk about fueling for this, you could do this a little bit more like fasting in the morning. You could to truly kind of work more towards like fat burning rather than under certain metabolic conditions. That would be
no, that's actually yeah. Before we wrap this up, yeah, I think it's actually worth noting just because if we're doing this fasted, we're essentially kind of moving to more that ketogenic, where we're kind of now using more fat for fuel. So if we can kind of deplete our sugar stores
mm-hmm.
and our muscles, it's going to really kind of force us and biasing now more oxphos, so aerobic respiration, in order to generate. So we're going to actually essentially kind of almost, I don't want to say inhibit our ability to fast twitch, but definitely decrease its ability, and it's going to then bias and favor more of those slow twitch fibers. So yeah, that's actually.
And then if not that you would want to do this consistently, but you could even the night before, you could do like basically a glycogen depletion like session,
Mm-hmm.
and then you could come back the next morning on a fasted system that you didn't recover and really like if your goal was truly to go after that beta oxidation, you could really like bias it again by changing your fuel source.
Yeah, that'd be interesting to see. I don't know if I've seen these studies, but it'd be interesting to do some studies where you're incorporating more of these fasted states of kind of depleting your glycogen stores, and to see if you can really optimize for developing slow twitch.
Yeah, so Keith Barr, I believe, has done some studies on this. Like he's a big connective tissue guy, but he's done some studies, and so it's not something that he recommends doing like consistently, but it is something that you can, if you're trying to truly like optimize, like you can like mix and match throughout your training cycle to bias a little bit more in this direction.
Yeah. Yeah. All right. Well, anything else you'd like to add?
Well, it really goes to show that like we can't truly isolate any of like everything. Like we have to be considering all these factors, our fueling, like what we're fueling with, and our training. So they really need to match. So we can't be fueling for fast twitch and be training for like we're competing, right? So when we're thinking of training for slow twitch, we need to be thinking of how we're fueling and making sure that we're not competing by using different fuel stores.
Yeah. All right.
I think with that, that kind of wraps it up.
All right, everybody. Thanks for joining us. Next time, we're going to kind of go into now training to failure. So we'll talk about fast twitch going to failure, what that's going to bias, also then slow twitch going to failure. And yeah, so stick with us, and we'll catch you next time.